Hello, grade 11. So this video is on Newton's second law. To start from the very beginning, you have to check the videos on Newton's second law. You just have to enter the playlist for grade 11 and check the videos, okay? We will continue from there. We were talking about Newton's second law, which actually relates the sum of the forces that are acting on a system to its acceleration. What do I mean by this? So if we say there's a sum of the forces that are acting on the system is different than zero, this means that the object or the system will accelerate. Okay, what do you mean by accelerate? It will change the speed over time. Okay. However, if the sum of the forces that are acting on the system is equal to zero, okay, this means there will be no acceleration. The object will move either at a constant speed or it will remain at rest if it's from the beginning it's at rest. Okay, let's do this application using Newton's second law. So these two girls, as you can see, are fighting over a pillow. Anuja is holding a pillow of mass 0.30 kilograms. So the mass of the pillow is 0.30 kilogram. When Sarah decides that she wants it and tries to pull it away from Anuja. So Anuja, here this girl is Anuja, taking the pillow, is trying to push the pillow towards her to the right, okay? And Sarah is taking the pillow to the left. Okay, and the pillow has a mass of 0.30 kilogram. So our system is the pillow. Okay, what do you mean by system? It's the object, okay, that the forces are being exerted on. Okay, Sarah pulls horizontally along this line, which is along the x-axis. That's what we mean by horizontally. On the pillow with a force of 10 Newton. If the force that Sarah exerts is 10 Newton, the magnitude of the force is 10 Newton, and Anuja pulls with a horizontal force also 11 Newton. Okay, so Anuja's force is 11 and Sarah is exerting a force of 10 Newton. What is the horizontal acceleration of the pillow? So we need to find the acceleration of the pillow. So acceleration, where or how will the pillow will accelerate? Okay, how the speed of the pillow will change and in which direction? Okay, first to solve these kind of problems, find the acceleration, and if we are given forces here, so we need to use Newton's second law. What do you mean by Newton's second law? It's F net equals ma. Okay, this is the formula that we need. F net equals ma. Okay, and don't forget there's a vector above F and there's a vector also about A. Let me put it here. And also a vector about A. Okay, this is the formula that we have to use. Now, okay. Now before solving this problem, we have to sketch the problem, okay? When you want to solve any problem using Newton's second law, first thing you have to do, you have to sketch the problem or you have to draw a free body diagram. What do you mean by free body diagram? We represent the object or the system by a dot, okay? By a simple dot. And you represent the forces that are acting on the pillow. So in this diagram, if we want to represent the forces that are acting on the pillow, what are the forces that are acting on the pillow? It is the force exerted by Anuja, okay, and the force exerted by Sarah, right? So these are the forces that are acting on the pillow, right? And of course, we don't want to forget that there's also the weight of the pillow, which is directed along the vertical axis, right? And it's downward. Always the weight الويت تبع الأوبجكت بتقل دايما هو النزول يعني it is directed downward. Okay, let's write these forces now. Okay. So F net equals to M times A. Okay, what are the forces that are acting? It's F Anuja plus, or F Sarah plus F Anuja plus Fg, which is the weight of the object, equals M times A. And here, forget there is a vectors on each of the forces, okay? There's a vector. I will put them at the end. Okay. Now, if you want to remove the vectors, we want here the weight actually is not represented, but if I want to represent the force of the weight, it's always pulling the object downward, okay? Vertically downward. This is the force of the weight. Okay. Okay, now if I want to remove the vectors, okay, here the forces have vectors. Now I want to remove the vectors. Next step, I want to remove the vectors from the forces and put direction, okay? If I choose positive direction along the horizontal line, the positive direction to be to the right. Okay, I choose the positive direction to be to the right. Always we choose a positive direction, okay? So if I choose it to be to the right, Fs, if I want its direction, or F Sarah, the force of Sarah, what do you think? Where is Sarah pulling it? Pulling the pillow? Okay, the Sarah actually is pulling the pillow to the left, right? What do you think? Is it positive or negative? It's to the left, and the positive direction is to the right. So it's negative, right? Negative Fs. Okay, now when we put directions, okay, when we put negative and positive, we remove the vectors, okay? Plus Fa Anuja, the force exerted by Anuja is to the right, so it's plus, right? We chose this direction, the right direction, to be positive, so F as positive, okay? Or Fa, sorry. G, it's pulling the pillow downward. Fg, it is the gravitational force, or the weight force, okay? If we choose the positive y direction, okay, or the upward direction to be positive, Fg is what? It is negative, right? But let me show you how we write minus Fg y. Why did we put y here? Because to say that this force is along the vertical axis, it's along y. Okay? Okay. It's equal to mass times acceleration. Here, let me tell you something now. If the pillow is going either to the right or either to the left, let's study the motion of the pillow. It's not moving upwards or downward. It's along the x, moving along the x direction, along the horizontal axis, right? So Sarah or Anuja is moving the pillow either to the left or to the right. So the pillow is moving along the horizontal axis. What does this mean? This means that the pillow is not moving along the vertical, not moving along the y. So if it's not moving along the y, there's no acceleration along the y. So we said if there's no acceleration, what does this mean? That the F net, y along the y, okay, or the sum of forces along the y is equal to 0. There's no acceleration along the y, right? The sum of the forces along the y is equal to 0. What do we have? What are the forces that we have along the y? There's only the weight force, right? The weight of the object. So it's equal to 0. So Fgy is equal to 0. So we can cancel it. Minus 0, or we put 0. Okay? Is it clear? Now we are left with Sarah and F Anuja. F Sarah is the force exerted by Sarah is 10 Newton, so we just put minus 10. And F Anuja it's 11, so plus 11 equal to mass of what? Mass of the object or our system, which is equal to what? Mass of the pillow. That is 0.330 kilogram, okay? Or 0.3 times A. Now we want to find A. Minus 10 plus 11, it's obviously 1. 1 is equal to 0.3 A. So A is equal to what? 1 over 0.3. Okay, let's see the answer right now. So A is equal to 1 over 0.3, and the value is 3.3 meters per second towards Anuja. Why towards Anuja? Because it's obvious, because Anuja pushes the pillow or exerts a force that is greater than the force exerted by Sarah. Okay, F Anuja is 11, however, F Sarah is 10. That's why the pillow will accelerate to the right, okay, by a value 3.3 meter per second square. So this was an example on Newton's second law. I hope it was helpful.